Yeah, we're in Q&A.
Okay. I've had all kinds of trouble with this updates for 7.2. Dependency problems.
I run SUSE Linux. I never have a problem. I'm not a Red Hat fan. I bring SUSE up. Comes right up for me.
Do they have enough?
Yes.
Email you when you update them?
I've never signed up for their update because I usually get these updates free because we have it compacted in either test drive center or downstairs and brainstorm on Linux present.
So you normally have to pay for that?
No, I normally get it free.
No, I mean other people.
No, the updates, software updates are free. You can get on their site. I get on the site very frequently and make updates. Matter of fact, in the last class I taught a couple of weeks ago, I just showed them my logically got onto the SUSE site, put up a couple of updates.
Help.
And while I was still in there, after I did the updates, we installed a user-owned machine and laptop, and had my students all log into the laptop. I have the light SUSE's system configuration utility called YASP.
Wait, you want this?
I prefer their non-graphical one called YASP1, but YASP1 is going away as of the next release, which is 8.0. But YASP2, which is the graphical version, also is the text graphical, is much better than it used to be. Fairly useful.
Concerning Mandrake fans, 8.2 is downloadable now as of like 2 minutes ago.
Mandrake 8.2 is downloadable. Mandrake's another excellent release. Matter of fact, I believe that Mandrake 8.2 also includes Star Office 6.0. I tell you, SUSE does not, and I'm pretty sure Red Hat does not.
I don't think the downloadable version.
The downloadable one won't. No.
If you're a member of their
Yeah.
club or whatever that is, then that downloadable site does have Star Office.
Oh, actually, I don't remember the club, but I didn't know it was a separate site.
Yeah.
Now, Star Office 6.0
Yeah. Here we go.
will be sold. It'll cost money. However, OpenOffice is still free. I have not downloaded OpenOffice. I'm still using Star Office 5.2. But as a member of the Northeastern faculty, what I might do is get a free copy of it.
Hey, does anyone know if there are any functional differences between OpenOffice and Star Office?
Yes, there are.
You know what they are?
We're not going to tell you what they are.
There are features that are available in Star Office 6.0 that are not available in OpenOffice.
Such as?
The one I heard was font rendering. Font rendering should be better in Star Office, but some of the features are, like the filters are supposed to be more updated in OpenOffice.
Okay. Okay, before we start, before I introduce our SUSE speakers tonight, what I'd like to do is introduce Anita Chen. Sorry about that. Anita is doing a thesis on publishing on Slashdot. And I thought that her presentation was interesting, so I invited Anita to stop by the meeting tonight and give about a 5-minute talk about what she's doing. Anita's a graduate student here at MIT.
I'm only going to take up a couple of minutes.
Okay.
Your agenda is full. I'm a master's student at the Comparative Media Studies Department, and my master's is on Slashdot and distributed construction of news and the exchange news on Slashdot. And I actually emailed, the way that Jerry found out about the work I'm doing is that I emailed a survey out to one of your listeners, so apparently it's not the correct or So I don't know if anyone can actually see it, but it was basically a survey that I was releasing to a number of local Linux users groups about the site, which is sort of 10 questions, basically about people's use of the site, and their opinions about editorial process, content on the site, blah, blah, blah. My thesis work is basically, my research is on two aspects of it. Sort of one aspect is the collaboration that ends up happening between users of the site and editors, and the changes in content that end up happening via that collaborative relationship, if you want to call it that. And the second aspect of it that I'm looking at is this notion of decentralized editorialship, and something that probably is more behind the scenes, but kind of looking at differences in editorial processes that end up happening in newsrooms as opposed to amongst a collective collection of editors at Slashdot. So those two aspects are kind of what I'm looking at. I wasn't sure if anyone in the room might be interested in speaking to me about their use of the site, people who don't use the site anymore, or who used to have used the site, or people with fairly virulent criticism. Most of the people I've spoken to are college age. I've spoken to maybe 2 people who are not, and I've spoken to about 20 people at this point now. So you get the right. So I'm looking for more diverse opinions, I guess. And if anyone was interested, my email address is Anita1, at MIT.
Want to write it up on the board?
Yeah, sure.
Here, let the crypt do it.
And if anyone had any questions that they just wanted to throw at me now, that's cool too.
Did you say there was also a survey you were like an
Yes, exactly. That's basically, so the survey doesn't, I mean, you could, yeah. The online survey.
It's online.
Well, I emailed.
Oh,
so,
I see.
yeah. So, yeah, it can be strictly just responses to questions in online or in a
I'll
text format.
I'll post Anita's original message on the discussed list, made with a couple of changes to say that Anita talked in our meeting. So.
Do we get to submit our responses as anonymous cowards?
Yes. Yes, you can submit your responses if you want to be that cagey, but you're really welcome to do that as well.
What's that, anonymous coward at linuxsoup.com?
linuxsoup.com.
Yeah,
Well, the editors, I've spoken to the editors already, so they all know I'm working on this. I don't think it's probably going to, they'll see it when it's in the finished format.
They haven't claimed you for it yet.
So I would welcome that kind of exchange.
Would you come back to us when it's done?
Sure, yeah. I actually have to run back home and finish up another chapter tonight, so
Okay.
fingers crossed. So I can't actually stay for the rest of the meeting, but I would be interested in finding out what we do.
Do you have your data at home mirrored so that if one of your hard drives fails that it's safe? Maybe you should stay.
Wink, wink. No.
Nice segue.
Thanks for the hint. I don't know. So, sorry, I hope that's enough information. I know it's fairly brief, but thank you.
Thank you very much, Anita.
Take care.
Okay, now what I'd like to do is, I guess we've got a quorum, so I'm going to just bring up Christoph Doerbeck, Mr. Linux guy, and
Also known as anonymous
Gordon.
coward.
And we'll get on the discussion of enterprise Unix and the stuff that Christoph posted to the group earlier.
Can we give them like just a bit of this?
Yeah, Gordon knows how to do it. He did it a minute ago.
Okay. You want to see?
Click the thing.
Would be nice.
Actually, it's better.
How's the weather outside tonight? Is it still snowing or is it raining now?
It's raining here, but it was about 2 or 3 inches out of Marlboro, Chris,
Yeah,
as you probably know.
yeah, I've got my snowboard packed in the truck right now.
Just listed down there, Providence.
Yeah. All right, well, good evening and thanks for coming out here tonight. We do have quite a bit of material we need to cover, so without further ado, I have 3 presentations we're going to be covering tonight.
Look at the camera.
I don't want to watch. Camera's bad. I'll stand behind you. All right. Basically, we have 3 presentations. One is an attempt to kind of define and quantify the term enterprise Unix or enterprise computing. And then in that same theme, we're going to talk about Kickstart, which is a tool for automating unattended installs of Linux. And then in our last segment, Gordon's going to be talking about the logical volume manager and specifically more on the topic of using RAID tools. Just so you know what's going on here. I brought 2 machines in. This particular box here has got 2 IDE hard drives in it. We'll be using this for the RAID demo and for the Kickstart demo. And this box here effectively is a server which is just running NFS and has all the CDs for the Red Hat product installed. So that being said, go ahead and flip up to the home, go home. The home button right there in the corner. There you go. And go over to the definition directory and the t1.html. The documentation that I have up here is available on my website, which is www.linuxduke.com. It's in PDF format. It's all written in DocBook, so I converted it to HTML for tonight. All right, so a little bit about myself first. My name is Christoph Doerbeck. I've been a system administrator for about 10 years. Started off in the education department down at the University of Texas in Arlington. Did a couple of contracting jobs at BDS, also worked in retail space at USA. And my wife was working for the airlines, and we ended up migrating up here to the Northeast and got stuck when we had kids. So, I also like to make a disclaimer about any presentation I do give because this is kind of a hobbyist thing for me. You know, Linux I do at home, and even though I am doing it at work now, what I present here is mostly my personal experience from what I've done at home. And therefore, I do kind of request from you that if you do take any stuff you learn here, that, you know, make sure that you know what you're doing and don't just rely upon me to give you sort of accurate information. All right, so let's go on the next page. All right, so first piece, we're going to talk about enterprise computing. And I spent about the last 2 weeks trying to prepare for this presentation. And I was unable to find a really good definition of what enterprise computing is. And you seem to see the term in the press a lot, where everybody's asking, is Linux ready for the enterprise? Or Oracle's trying to advertise their Oracle 9i on Linux for the enterprise. So I was trying to figure out exactly, what does that mean? And basically what I've done is kind of come up with what I consider to be the essential components for enterprise computing. And what I'm going to do is kind of drill down in each one of those components. And then hopefully when we're done, you can kind of agree or disagree with what I think enterprise computing is. And we'll talk about it while we get set up for the Kickstart portion. All right. Next. Is it not the next thing? Okay. So let me be honest and tell you that when you ask what is enterprise computing, I really don't know. But what I do know is when people talk about enterprise computing, usually you see the following list of topics pop up. People talk about service level agreements, some level of availability, performance and scalability, monitoring backups, capacity planning, storage management. I mean, the list is up there, you can see for yourself. So, like I was pointing out, these are the things that I'm going to drill down to now, and hopefully when we're done, all these topics combined as well as the subtopics will help us come up with a good definition of what it means that something's enterprise ready. And when somebody asks you, well, is this product ready for your enterprise? If your enterprise follows this diagram, you can pretty well say yes or no, it fits this litmus test. So, all right, next. Okay. So the first topic here was the service level agreement. I've also used this category to kind of lump in other topics that didn't fit into my other categories because they would pop in my head and I didn't have time to create another subtask for them. So, service level agreement is an agreement between the provider and the customer, and basically you're promising, guaranteeing some level of service, whether it's a number of process, performance-based service level agreement, application availability, access to your help desk, you name it. There's all different parts of your service level you provide for your customers. So I think to begin talking about enterprise, you have to start here because everything you do in your enterprise is based on what you're doing for your customers. So I've outlined a couple of other questions that you might want to think about. 800 numbers, remote access for your admins, remote access for your customers, escalation procedures that need to be outlined. This is one of those categories I just threw in there. If you have a problem in one area of your enterprise, you've got to have a clearly defined escalation procedure for resolving that particular problem. You can't be in a situation where you don't know what to do. Because if you have an area where you don't know what to do, then you're in clear contrast to some service agreement that you have. So, and also consider how many machines, and in addition, I put the last comment in there, this lights out management adapters. That's mostly a PC term. I don't know if you're familiar with compact hardware or IBM hardware. They tend to sell PCI cards that would stick in. They kind of substitute your keyboard and mouse and monitor and allow you to tell it in there and basically manipulate the box as if it was local. Kind of a PCA or a hardware solution. So, just some things to think about. All right, let's go to the next one. Availability. This is probably the most important category when you talk about SLAs. You're going to promise that your equipment is available X amount of hours a week, a year. I have the infamous nines up there. A lot of companies consider 5 nines to be good uptime and availability. That's 99.999% of the time. And I don't remember what the actual numbers boil down to.
5 minutes down.
And so 5 nines availability is like 5 minutes of downtime for an entire year.
6 minutes.
Is it 6 minutes?
No, 6 nines.
6 nines is 5 minutes?
5 nines gives you almost a day's downtime.
Days down. Okay, great, thanks. Everybody hear that? So 6 nines is 5 minutes, 5 nines is almost 24 hours. What's that? All right, so that's the availability piece of it. And when you talk about availability, obviously you can break it down to actual server availability or application availability. Some applications are easy to switch from one physical system to another, especially if they're available on your network. So your customer sees almost no downtime while something fails over to another box. This is where you get into system clustering and that kind of technology. And then, of course, another piece of your availability is identifying all your single points of failure, otherwise known as the spots, and also having a good risk assessment and management team. Traditional techniques for improving availability. Number one on the list is, climate-controlled data centers, things that help your hardware live longer. Redundant power supplies or redundant hard drives and batteries and generators. There's any number of things you can do to help your system stay up longer. Unfortunately, every time you add another layer of redundancy, you're usually upping the cost of the hardware that you're purchasing. Server class hardware with redundancy, again, this is the hot swap disks, power supplies. Even now you've got the hot swap PCI cards. So if your network card fails, newer systems allow you to actually take that slot offline. You can replace your card while the system continues to run. And clustering technologies like, let's see here, clusters. That's what I was mentioning before. Applications can work between one box or the other. So if there's any number of software solutions to automate that process, where if you know a system's failing and you have to take it down for service, you can do a little point and click and migrate the application off of one system running on the other. HTTP, Apache is a perfect example. It doesn't matter which box it runs on, as long as the configurations are pretty much identical. And then you can, fail the IP address from one machine over to the other, and customers don't see any interruption in service. HA software, this is a high availability software, usually employs some type of special communication between two boxes so that they monitor each other's health. And if one box knows the other guy just panicked and failed or crashed, then the other system only has to start the application. It doesn't necessarily have to reboot the entire machine. So if my box over there has a CPU failure or something of that sort, the system over here will notice that, come up, bring everything online, and again, everything happens within minutes or even seconds, and the actual outage to a customer is very minimal. Veritas, a local company, has a clustering product called VCS, which is pretty popular. I think Legato has another one that's pretty popular, and of course, IBM has their HACMP stuff for R6000s. None of those are available for Linux, except for VCS, which is almost out the door. Okay, and then the last piece here, an important technique for improving availability, obviously, is to hire, train, and retain responsible, capable employees. You can hire all the great employees you want, but if you can't keep them, then that turnover process really kind of puts your availability in jeopardy, because you lose somebody who knows your environment. If the problem does happen, you might not have the new hire in a position where he can actually deal with the problem. All right, next. All right, the performance and scalability section. Talk about enterprise computing. Consultants come in and they give these great, big, wonderful, presentations on scalability. Basically, it breaks down to two terms. One is vertical and horizontal. Vertical scalability, in a physical sense, is more CPUs per system. You've got one application, like a database server. Databases don't do so well when they're distributed across 5 servers, or especially if you've got one big database, it's hard to take it down from one system and switch it over to another. So basically, when you talk about vertical scalability, you want everything in one big box with as many CPUs and as much memory as you can have. This adds to very complex hardware, complex software. For those of you who don't know, Linux still has a small problem of scaling to a large number of CPUs in a linear sense. That's probably the next topic down there. Is often measured in terms of linear scalability. This is a pretty simple formula that basically measures the actual system performance versus the number of CPUs you have in the box. So if you continue to add new CPUs, you double, add another 25% of raw processing power. And Linux, even with the 2.4 kernel, pretty much scales about 4 CPUs, but even then it starts to tear off, and the more CPUs you add, you're not necessarily getting as much bang for your buck as you should. And then the last comment here is obviously that there is a limit. Whether it's a hardware limit or a software limit, you can only add so many CPUs to your box, and at some point, you're not going to get any measurable gain out of it. Another consideration when you're talking about vertical scalability is, some applications don't thread well in an SMP environment. Adding more CPUs to an application that's not threaded doesn't help you, because it's going to get locked on one CPU and just keep running there. So, that might be a perfect opportunity to do a horizontal scale, which is having multiple number of boxes running your application. You consider like an Apache web server or something, or like a web server farm like Slashdot. They've got their, I don't know how many servers they have, but they've probably got more than 2 servers running Slashdot. Yet to you, when you connect to the environment, you don't know, you think you're connected to the same box. But on the back end, they've got the application spread out across any number of systems. And this is where Linux really excels. Because Linux is low cost, runs on low cost hardware, it's easy to put up 20, 30 boxes and scale your application across the system. And performance is achieved through network infrastructure and application design. There's a number of products you can purchase. I think there's one called Big IP or something. It's like a hardware front end you put on your network, and it basically does the load balancing for you. So connections for your website come in through the Big IP box, and then it kind of round robins through all the systems that serve up your web server, and it does that for you. So now there's really nothing on the OS side doing this. All the intelligence is built in on these little proprietary boxes. And I think there's also some solutions which actually run on Linux, like was it Piranha, something like that. Does the same kind of thing. You have a number of Apache web servers running behind the central node, and then the load is balanced across those. One of the things you might run into with horizontal scaling is access or shared access to read-write data. Perfect case is a database. In a Oracle parallel server, you can have multiple Oracle servers accessing shared data, but unless you're a big shop and you can afford the cost of something like that, you're probably running one database which has a read-write lock on your data, and maybe some other databases that have read-only locks. But again, you have to face that problem of how do I share the data across that many systems. Consider NFS, might be a good solution, performance isn't all that great. There's other intrinsic problems with NFS. And of course, it's always important to identify all your single points of failure. Yes?
With NFS, which apparently doesn't scale all that well, you start putting upwards to 11 or 12 boxes on it, and you end up, by definition, ending up with blocks. Is there any other solutions? I've looked at things like Intermute and ASS and things like that, and none of them seem even as robust as NFS. Do you know of any?
I do not, no. There's the Unix Global File System project, I don't know where that's going.
Check out the Sistina website where the logical volume manager is. They've got a global file system project that I don't think it's there yet, but I think it's on the way. TINA.com.
I'll write that up on the board. The question of how do you deal with shared data if NFS isn't really an option for you? The comment was made that NFS really doesn't scale well without the lemon boxes.
We just put our...
And basically the response was, I don't really know of any open source solutions, and even in the proprietary world, I don't really know of any awesome solutions. You could consider something like a network appliance with multiple network interfaces. That might work well for you. Or simply putting multiple network interfaces in a single box. I really don't know. So, okay, that's the Sistina website, so there's the global file system. And of course, when you talk about enterprise computing, you're oftentimes connecting your boxes to what's called the SAN, or Storage Array Network. Is anybody not familiar with what a storage array network is? Okay, real quickly, it's kind of like NFS, except it's all implemented through a proprietary fiber channel link that basically puts network storage on a network. It's a block level device. Basically, you put these giant silos of disks on a wire, and then you share your boxes by connecting them to the SAN. So you don't have any locally attached storage. You can have all of your SAN disks in a completely different room or even a different location. And provided the SAN can be extended into your data center, you can just have racks of systems that attach to the SAN, and it's all the same concept. They've got fiber channel switches and hubs, things that help segregate traffic on the SAN, and also help boxes that you've got a giant silo of 1,000 disks. You don't want your system seeing 1,000 disks, because every time it boots up, it's got to go down and probe them all. So they have all that in the SAN architecture, which is mask, LUNs, and do all that kind of business in boxes. So same concept as local attached storage, except it's managed differently. Okay, let's get back to the screen here. All right, and identify your spots. Okay, next. Monitoring. In any enterprise, you really need to know what's going on. And you can't be caught off guard where your system's been down, especially if you're promising that your system's going to be online at a certain amount of time throughout the year. Comment that I've run into most is, a lot of enterprise shops who have been around for 10, 20, 30 years or more, they're not going to remodel the process that they've developed over this year, all the knowledge base that they have just to run a Linux box. So, you kind of have to think of this when you consider whether Linux is enterprise ready. Linux might be ready for its own enterprise, but is it ready for yours? Can it integrate into your place of business? There is, in the last 9 months to 12 months, the last year or so, there's been a lot of movement in the third-party client software piece. Tivoli, TNG, Legato, they all have Linux agents now. Unfortunately, in a lot of cases, you find yourself that they support Red Hat 6.2, they don't have Red Hat 7.2 support, or they still support Red Hat 6.0. So it's kind of a battle to always deal with the third-party vendors.
Can you repeat that, please? I didn't catch that.
What's that?
Can you repeat what you just said?
Well, one of the things you run into with third-party software is that some of them will support Red Hat 7.2, and some of them won't. Some of them are still, supporting Red Hat 6.2 or 6.0, and are having a problem, getting their products up to speed for the newer releases that have come out. One thing that we all know is that Linux moves at a very rapid pace. There's a new version of Linux coming out almost every 6 months, and there's more kernels coming out all the time. And it's a big task to stay on top of the distribution and stay current with patches and all the new hardware support and stuff. But like I said, the third-party piece is coming along. Most of the big enterprise players, thanks mostly in part to IBM and all the money they put into it, they've jumped on the bandwagon for Linux and have now made their clients available. So you'll find products like Tivoli, TNG, and what are some other monitoring stuff? So let's go ahead and move on. BNC, yep, that's another good one. Even the BNC Control-N stuff. Is that what you're saying? You said Control. The Control-N, they have a client for Control-N too. So BNC is a big player in the enterprise.
I think that's going to, in the future, that's going to grow much faster than it has because of IBM, because of HP Compact. Some of the big players in the Unix marketplace are starting to look at Linux as being a major operating system within their offerings on their platforms.
And there's going to be a learning curve, required too for these third-party companies, because they're going to have to learn how to deal with Red Hat changing glibc every 9 months. They're going to have to learn how to deal with that kind of stuff and make sure that their release cycle kind of lines up with Linux, because in your enterprise, your customers are going to want the features that Linux provides, especially when the next kernel comes out, 2.5, 2.6, whenever the scaling is going to support 32 or 64 CPUs. Whenever that next big performance gain comes in, your customer's going to want it, but you're not going to be able to offer it because you have to wait for all the good features like that. All right, so monitoring, big piece. That's the box has a problem. Alarm goes through your network, pops up on somebody's screen, they know who to page, get on the phone, make a call, you resolve the problem. That's the whole process. Okay, moving on. Backups, another important topic. You need to be able to provide all backups to your environment. The enterprise shop already have a process in place for backups. They're not going to come up with some new custom design thing to support your first 100 Linux boxes. If you're going to replace everything with Linux, then maybe you want to consider something new. But for the most part, you've got to be able to innovate. So you've got to, again, rely on the third-party vendors to produce clients that run with your Linux boxes. And again, a lot of that is now with a lot of good momentum. I really haven't found any of the major backup players that don't have a client for Linux yet. And then the last question, of course, is the off-site storage management. Any place has some process for taking the tapes off-site, storing them somewhere safe. Right, next one. Capacity planning. That's always an important part of any enterprise, because when you consider an enterprise, you're usually talking about a lot of systems. Anytime you have a lot of systems, you have a life cycle of a particular box. You can't just roll out 1,000 systems in a month, and then a year or 2 years later, when the systems are old, you don't replace all 1,000 systems at once. You've got this whole process running all the time. You're always purchasing equipment, you're always getting rid of the old stuff, and you've got to be able to manage all that. And part of that is making sure that when you purchase equipment, you buy the right equipment for the right project. You don't want to buy equipment that just sits idle. If you do that, you're wasting money. So part of that is this capacity planning category. Comment there is you can't just throw darts and pick what kind of hardware you want. Purchasing hardware size, poor and cost prohibitive. You need the tools to accurately measure whether a box is performing well or not. SAR is a standard Unix tool. It's a system accounting and reporting. It's become part of the standard Red Hat distribution. Basically, it's a little cron job that runs every 5 minutes, does a quick scan of the box, saves things in the database. You can see the system, at 3 o'clock, the system was this busy, there were this many I/O requests, this much swap available. It's a good general feeling for how busy the box is. but it's not very granular. It's not going to tell you what's consuming the slot. It's not going to tell you what process is taken up in the old part of the system. There's a lot of things that STAR can't offer you. And later on, when I get down to my final topic, which is root cause analysis, STAR isn't going to provide you the clues that you need to find out what caused your box to crash. So again, you're depending upon either some open source project or as an enterprise, you want to use the same tools you use everywhere else, depending upon your third-party vendors. Another comment there is the old historical baseline. Companies that are starting to deploy Linux don't have a long history of dealing with PCs and Intel processors and the 2 gigahertz processors. How much real computing power do you have when you're trying to run Oracle? 2 gigahertz processor running Oracle from Intel is a lot different than an 800 megahertz processor from Sun. The characteristics are different. One has more cache, one has less cache. One has a bigger memory bus, and the other one doesn't. There's a lot of pieces involved, and your capacity planners have to understand this and know that when they're speccing out a particular box, whether they're giving you the right thing or not. And that usually comes about through some type of history. Guy knows that the last 100 boxes he rolled out with Linux on, this worked well. So, it's that history, and you don't have that right now in most places. But again, it's coming along nicely. And then, of course, the people who understand the baseline make up accuracy. And that boils down to retention and training again. To be able to keep those people, you also need to train your new people so that they learn how to do all this. All right, next. Storage management. This is a big topic in any enterprise. Typically, you don't deploy 1,000 systems with a bunch of internal IDE disks. You either have some type of large-scale storage locally attached, which we're talking about like a network appliance, or locally attached SCSI storage with RAID hardware integrated into it, or on the larger scale, if you're talking about that SAN again. You've got 1,000 systems that are all attached to the SAN, but you do need the means to manage all that storage. You're not going to do it by managing it disk by disk. So that's where a company like EMC makes all their cache, because they provide you large-scale storage solutions, and they also give you the software to help you manage it. If a disk fails, it's almost oblivious to a PC over here. If a disk fails in the SAN, a little blip shows up on a completely different screen that goes to a different group, where some guy's got a box of disks, or he dispatches, some vendor to come in and replace the disk, and all they do is they throw the disk with a blinking light, pop it out, pop a new one, and they go home for them. So that's true storage management on the large scale. But not everybody can afford that. So in the case of Linux, you've got products like the RAID tools, which we're going to talk about tonight, and also a new developing logical volume manager. And the whole logical volume management piece is basically to take, what was your definition for it?
It abstracts the physical disk. It gives you a logical volume layer between your file system and the physical partitions. So you lump your physical partitions into a big pool, and then the file systems talk to the logical volume manager to then extend or shrink or...
Yeah. To give you kind of the novice approach, think of yourself as a home user who's got a box full of 2 gig drives. Well, if you can take all those 2 gig drives and plug them into a system, or consider them to be SCSI drives because it's easier to see if you can plug them all into the system. But you get all these 2 gig drives with logical volume management. You can bind them all together and make them look like one 100 gig drive to your system. That's the concept behind logical volume, because you abstract the whole what this pool of disks are, and you either combine them or divide them, or combine them all and then subdivide them so that the system gets what it needs. So that's the logical volume management piece. Another piece of storage management is the journal file systems. This is a big thing for enterprises. Journal file system, in a nutshell, is, it's hard to describe in a nutshell, I shouldn't have said that. The concept behind the journal file system, well, let's talk about a regular file system. Everybody knows if you unplug your PC, plug it back in, your disks have to run the FSCK when the system comes back out, just like a Windows box where it has to run check disk. And that runs to your system and says, oh, you've got all these files here, I don't know what to do with them. I'll either dump them in, Unix terms, I'll dump them in the lost and found file, or I'll be able to repair your disk, or in the Windows sense, it creates all those check disk files, or file 000 through 1,000. And of course, those are all your DLL libraries, so Windows doesn't boot anymore. But what the whole point behind the journal file system is to improve the speed of your FSCK. And the way it does that is journal file system maintains a journal. It's basically a little table of the most recent I/O interactions with your disk. So if the disk does fail, all the FSCK has to do is look at the journal and say, oh, only these parts of the disk have recently been modified. I don't have to go scan the whole disk looking for these possible errors. I just have to go look at these little pieces here. So a journal file system will usually be able to check itself in a couple of seconds, whereas an FSCK on a multi-terabyte file system attached to your SAN can take hours or days. So that's an important piece for an enterprise, especially if you're talking about your SLA. You know, systems crash, it happens. But if you're going to waste your whole SLA time for the system to do an FSCK, that's a clear and present danger. You know, you want to be able to have journal file systems. Big piece. Number of journal file systems have cropped up recently. ext3 is a journal file system. RiserFS is a journal file system. IBM has its. XFS. And then Silicon Graphics is released there. Silicon Graphics. XFS. So even the main players in the Unix world have ported their JFS over to Linux. Red Hat's still standing true behind ext3. The nice thing about ext3 is it's backwards compatible with ext2. So if you have a problem with the journaling, you just go into your etcfs tab and say it's no longer ext3, it's just ext2. System reboots, now you have a traditional ext2 file system. So that backwards compatibility kind of gives you a nice warm fuzzy feeling, but you know, you really want the journaling. You shouldn't have to turn it off.
One of the things that you need to mention is that these journal file systems are slower than the non-journaling file systems. And you have to look at which speed of each one that they have been benchmarked. And JFS from IBM, I believe, is one of the better ones for speed. But I don't really recall the statistics.
From what I recall, RiserFS accelerates at file systems that have thousands of teeny tiny files because it's an algorithm based on a binary tree. ext3 is backwards compatible, file system structure is the same. It's pretty much just ext2 with journaling, but even then the performance isn't bad. And what you gain by it is definitely a big win. So only in cases where your disk I/O is, you know, a severe penalty for your application, in those situations you need to consider whether or not you want to turn on journaling or not. So, good point. All right, and again, the last point, you know, we're not remodeling to integrate Linux, so again, we've got to be able to fit in with the existing area. One other comment, hierarchical storage management systems. This is, you know, the fancy of a lot of enterprise shops because they usually equate, you know, pennies per megabyte, and tapes always come in cheaper than hard disks. So if you've got a system that can basically say, you know, that this data has been accessed in the past 10 years, why does it have to sit on the disk? It can migrate its way to tape, and then when the request comes in and somebody wants to use that disk, it's going to find its way back here. There's actually a completely automated system for this, and that's what this HSM environment is. And there's a number of different vendors trying to produce things. I think HP has a big one, but yes.
Journaling file systems, they only help you recover faster, they don't help you recover more data better?
No. My understanding from journal file systems is that they still have the same problems as regular file systems. They just do it a lot faster.
I think it depends on the particular journal file system, actually. Some of them use the journal for not only write down what the blocks are changing, but the actual data that changed in the journal is just a sequential list. And that way, since accessing this sequentially is very fast, you can write out the journal entry very quickly, whereas when you go to update the actual file of this, you have to seek all over the place. So there's a very good chance that the data will have gotten to the journal before it actually got into the regular file system. And as a result, you can then take it out on the journal and put that disk and get actually more up-to-date information than you would.
Sounds a lot more like the database transaction log.
Yes, I don't know which journal file systems support that capability. If that was a concern you want to check.
I believe when they direct the actual data out, they're writing on
data that you want to file. You have a lot of files, you decide to place the middle 200 megabytes right into that. But I'm not going to change the file structure, the directory structure, all that. So that's what you lost in the file.
The details of that I really don't know. My understanding has always been that that journal file systems really don't offer any much more protection than the regular file systems. But the goal is always to improve the recoverability
And minimize the chances for directory structure.
Right. Okay. Let's go ahead and move on. Product lifecycle management piece. This is what another. Usually you have a different capacity group in your company that does the same thing, and they help you manage the life cycle of your PCs, your software ages, your hardware ages, your operating system ages. You've got to be able to manage all this stuff. Like I said, you don't deploy 1,000 systems one week and then do it again 2 years later. You've got this whole process going, so you've got to have people who can watch that, that your compact machines are out of warranty next month, and that you've got something in the works to get those replaced. Vendors make improvements to release new stuff, stop supporting old stuff, and when they do stop supporting old stuff, your SLAs are at risk. If your system crashes, you call your vendor and they go, oh, we don't support that anymore, you're not going to be able to meet the deadline because they're not going to come in 2 o'clock in the morning and fix hardware that they're not supposed to support unless you're paying big bucks. So, maybe that's the way you're going to meet your SLAs. Pay tons of money for support that you shouldn't have to if you were able to manage your environment. Let's see what else. And we all agree that buying cheap PCs is not feasible for any enterprise. So this whole product lifecycle management is really an art that balances, the cost of your systems with the longevity of your hardware.
We've got a section on enterprise class hardware later.
I think so. Go and bring it up in a minute. Don't deviate from the plan.
Stay on target.
All right, this is my favorite topic, root cause analysis. I could go on for at least a minute or two on this particular topic. Root cause analysis to me is that when I have a system fail, I've got a procedure in place so that I can find out exactly what caused that failure. And that's the nice thing about big vendors like Sun and IBM, is they pretty much have got it nailed down to a science. But if your system panics, you can retrieve core files, console output, any number of other clues and stuff in the system crashing, that when you bundle all that up and send it to IBM, they could pretty much turn it around in about an hour or two and tell you exactly why your system failed. And usually they'll come back and say, I don't know what happened, but you need to upgrade your kernel patch. You need to upgrade the latest kernel, the latest systems. We can tell that you don't have the latest security updates. That do that first and see if the system fails. And another one of my topics down here at the end is the actual vendor management piece. And that's when you have to yell back at them and say, no, you go find the guy who knows how to do this stuff. You have him give me the answer.
Because we've got 50 other machines at the same level, and they're not having this problem.
Right. So root cause analysis is the end all to me of real enterprise computing. If there's a situation where I can't find out what caused the problem, then that system does not belong in my data center. So, how do you identify exactly what happened? Was it memory leak, poor performance, system panics? All those topics deal with root cause analysis. Some of those tools, like the monitoring tools or the pieces that detect the landmark, or those kind of things. Those things can help you because they'll tell you, as the system runs almost real time, give you a quick, history. They'll tell you what processes are taking a swap and stuff like that. So in those cases, you've got better tools. But in the case of Linux, if you have a kernel panic, my understanding is that there is still no true core dumps for Linux. They do dump things to the console, these little oops messages. And that's a big improvement because they used to not even have that. The system used to just go blink and reboot. Now, granted, it didn't happen very often, but still, if it does happen, you need to have some type of a response and how to deal with it. So let's see here. Identify what clues and evidence are required. So, you need to know what it takes to come up with your root cause. And then, of course, you have to remember what your SLA is. You got to remember, who's your guru, and how many gurus do you need. If you run a shop that's 24/7, you're not going to have the same guy being your guru all the time. You got to hire a lot of these guys. Kernel core dumps are often overlooked. I already made that point. Native Linux kernels do not have core dumps, and most importantly, faults in the kernel reports are often lost in the system console. System crashes, makes that nice little oops file, but then continues to reboot. You've lost the key components, your clues. Yes?
About kernel core dumps, I think some people at SGI did something, but it's not in any of the standard kernels that anybody ships as far as, maybe SGI does on their own hardware.
And I'll tell you why. Core dumps are a very complex piece, and every time you upgrade a kernel, you change the boot system map file, and you change other things that associate with the kernel. And so when you submit a core file to some vendor to look at it, you not only have to send them the kernel, but you have to send them the right system map file. And for people who upgrade their own kernels, a lot of times they just take a kernel a day, compile it, and install the image to boot with, but they don't upgrade the system map. Because usually if you're not changing major versions of the kernel, you don't have to deal with that, except in certain situations. And so if you don't align those properly, it's a big mess. And there's other problems with kernel core dumps. But you're right, SGI has been working on it. I went to a Linux World presentation from the gentleman who was doing it, I think it was about 2 years ago. And it was good stuff, but it does require you to build your own kernel, patch it, and install it. And right away, once you build your own custom kernels, now you're at risk with all the people who are supporting your version of Linux for saying, I'm not going to touch that. So one solution to help you kind of retain your oops messages on the screen is to perhaps configure your kernel to dump those messages to the console. Console being a serial port. And hopefully, if you're in the data center environment or even at home, you have your serial port connected to another PC that basically logs all the input to a file. That way, if your system crashes, you go to your alternate PC, and you can go capture that input there and then send it to your vendor for a quick peek to see what's going on. Okay, so the serial console can help. The Linux kernel definitely supports serial consoles. Live supports serial consoles. And those are kind of the steps in the right directions with this KSIM oops. And there is a utility also that maps oops data to an actual human readable, this process killed your box. So steps in the right direction. If it's the right solution or if there's a real final solution coming, I don't know yet. But this is my hottest topic with Linux in the enterprise. Because this is what I do for my living. This is what I do for a living. Because I don't analyze core files, but I gather those clues and send them off to vendors. So my job is to motivate somebody else to tell me what caused my system to crash. Okay, and this is of course the big total cost of ownership, or TCO. If you're talking to any business partner, that's their bottom line. How much is this environment going to cost me? So, you got to consider your one-time versus recurring costs. Compact costs more support than IBM, or HP costs more. These are all things that help you decide whether you're going to buy an IBM or a compact. It's not always just performance. Application consolidation might help. This is where if you have 10 systems that are all running Apache web server, but all your 10 systems are idle, maybe you have all your web servers run on one system. So consolidating all your applications onto one box. How about server consolidation? This is IBM's big forte these days. They're trying to convince companies to take 10 PCs and put them on their mainframe. So basically now you're taking all this equipment and consolidating onto a single frame machine. And you can either do that through hardware, where you're abstracting, or creating these logical partitions, or LPARs in the IBM terms. If you're a Sun person, you're creating domains. But these are other things you can that you have to consider. And then, of course, the last piece here are these virtual machines. Virtual machines. Anybody not familiar with VMware? VMware is a great, awesome product that basically allows you to run a PC inside of a Linux machine. You install VMware, basically boot it up, a little box, looks just like a PC, a little BIOS thing that comes up, and then you basically tell it, go install Windows, and it installs Windows inside of itself. And you can run Windows inside VMware. Well, you can install multiple copies of VMware in your box. So now you can have your one system running Windows, Linux, anything that runs on a PC inside these little VMware sessions. The company that produces VMware recently introduced a number of enterprise class VM solutions. So no longer do you need to run VMware on or inside of a Linux thing. Now you can run it in its little mini OS, which basically improves the performance of the VMware tons. And it also allows you to scale more slices per box. My understanding is that the latest version of VMware still will not show any one slice more than one seed. It's coming. Won't be long. And then you can buy, a compact 8-way PC and consolidate all your servers into a single frame, and perhaps save cost on electricity. Electricity is a big factor when you're having to pay for a data center.
Point failure with that.
That's one of your SPOF issues. Is if you buy a single framed Intel box, Intels don't do too good if they lose a CPU. It usually takes the whole system down. So now if you've got all 50, of your servers consolidated in a single system, you're at risk where a single CPU failure takes the whole box down. That's where you move to an IBM, where the CPU failure, oops, it just goes away. IBM brings in another one, migrates your OS from one CPU to the next, and it just keeps running. The Sun 10Ks and 15Ks do the same kind of thing with their domains.
Compacts and HPs do the same thing. Just pull out RADs or CPU boards while it's running.
There's a lot you have to consider when you talk about enterprise computing. A lot of that has to boil down to your service level agreement. What type of service are you providing to your customer? So let's go ahead and go into the last screen here. And so here's my review and final comments. I still don't have a good definition that I can tell you this is enterprise computing, so that when somebody comes to you and says, is my server or is my operating system ready for your enterprise? I really don't know how to define it because every enterprise is a little bit different. And what you consider an enterprise is different from mine. For me, enterprise computing is everything I've just talked about. It's the people, it's the process, it's the whole environment. And so when people say, is Linux ready for the enterprise? I still don't have really a good answer. It's ready for parts of the enterprise, and just about anybody will repeat that as well. But is it ready to basically replace any piece of your enterprise? Basically replace any piece of your enterprise? The jury's still kind of out on that. I was kind of hoping to open up a little discussion here to see what your comments are, if anybody's got experience with deploying Linux in the enterprise.
Touch a little bit about what makes enterprise class hardware in a hardware machine.
Well, we did mention the redundant power supplies and hot swap disks, and that we touched on that.
How would, let's say, serverless scale compared to Linux?
Well, if you look at like a 15K or even the new Sunfire boxes, I think those scale up to like 128 CPUs or more. That's my understanding. I think the 10K was 64 CPUs. Again, you got to consider whether or not your application will make use of that. Not every system's going to be able to, depends on the threading and the way that people wrote the application.
I don't know pricing for the 15K, for the Sun 10K would run you $1.5 million. So you have to determine whether you need that level of performance or not.
The 10K also offers that whole domaining concept where now you're at the, almost at the BIOS level, you're saying that these CPUs are one system, these CPUs are another system. You carve up your memory saying this memory belongs to that one and this one. And then when you start your system up, all these OSs are running on the same physical frame, but they're really oblivious to one another because they don't realize that they're all running on the same OS because you divide the hardware at hardware level. The IBM S390 does the same kind of thing where they create the LPARs, or logical partitions. So at the microcontroller level, they go in there and they basically turn off and on CPUs and then bind them to particular LPARs. And then you can run Linux on a native S390 LPAR, or you can install the VDM piece, which allows you to run as many copies of Linux as you want. So basically, with microcontroller, we go in and say these 10 CPUs belong to LPAR 0. I'm running VDM. VMware now can bring up any number of virtual machines or virtual versions of Linux on it as you see fit increase the performance. So, good stuff.